Welcome back for example 3. I had a little bit of fun with student names in this question, as you'll see. So let's begin. The temperature at the top of Mount Lady Nikita on the moon in degrees Celsius is given by this cosine function L of t. And take note that t is the number of days after sunrise. Part A, write down the range of temperatures experienced on Mount Lady Nikita. So obviously we're after the minimum and the maximum. Now you could hop onto your calculator and graph this, but it is just a basic use of what you know about the graph and the fact that it has an amplitude of 175. So we know that it's going to go up to 175 and down to negative 175, and then we're subtracting 75 from those figures. So 175 minus 75 gives us 100, and negative 175 minus 75 gives us negative 250. So we know that this graph is going to go from negative 250 up to 100. So answer the question clearly for the examiners. The range is inclusive, negative 250 up to 100 inclusive. Part B, calculate the temperature 1 week after sunrise. So 1 week after sunrise we know is at t equals 7 days. So at this point we can, as I mentioned before in example 1, when we know that we're dealing with several parts to the question and we're going to pick up our calculator, that the first thing we should be doing is actually defining this function L of t on our calculator. So enter the rule. So firstly, menu, actions, define L of t, but remember replace the t with an x, is equal to negative 175 cos of 0.23x minus 75. Done. So now my calculator knows that L of t has that rule. And now when we want to find the temperature 1 week after sunrise, all we're doing is L of 7, and it's negative 68.14. So that would be your answer here. Then the question moves on to another function for Oreo's crater, and it's asking us which of the two locations experiences the lowest temperature. So we need to find the minimum of this function O of t as well. So like we did before, we know through the amplitude that we're going to go from 172 down to negative 172, and then we need to subtract 80 from that. So we have 172 minus 80 is 92, and negative 172 minus 80 is negative 252. And so this is 2 degrees colder than what we worked out up here for Mount Lady Nikita. So it's Oreo's crater has got the coldest temperature, or the minimum. Then part D goes on to say, well, calculate the first 2 times at which the temperatures at Mount Lady Nikita and Oreo's crater are the same. So in other words, find the intersection points of these 2 functions. So I'm going to hop on the calculator and I'm going to define the Oreo's crater rule first. So O of x is equal to, what was it, 172 sine of 0.23x minus 80. Done. So I have both L of x and O of x defined. So then I'm going to insert a graph page and I'm going to graph those 2 functions. So the first one is L of x, and I'll adjust the window in a minute, and the second one, if I tab there, is O of x, and then I'll go to my window settings, and I know that's got to be a 0. Not too sure here in terms of what the domain might be. I'm talking about number of days after sunrise, so really just choose anything there for the moment. Let's go, oops, didn't mean that, 20, enter, and still not good enough, so let's try zoom fit, and I get a clearer picture there of what's going on. But notice I've only got one point of intersection, and the question's asking me for the first 2 times, so obviously going up to 20 is not enough. So again, you could either just grab those axes and move them around until I get that extra point of intersection. I'm also going to grab these labels and just move them out of the way. Now notice here that obviously the blue graph is L of x, it tells me, and the red graph is O of x, so it's really clear which one is which. So to find those points of intersection, analyze graph, intersection point, one at a time. So let's find that one. I'll just put that down here, and the next one is that value there. So to answer the question is saying the first 2 times where they are the same, give your answer correct to the nearest hour. So this one here is 10.11 hours, so 10 hours, and this one here is 37.43 hours, so 37 hours. So your answers for this section here would be 10 hours and 37 hours. They're the first 2 times that the temperatures are the same. Next we have Noya, our little space worker, is told to go and wait at Oreo's crater until the ice melts, and a reminder that ice melts at 0 degrees. So how long will he be waiting at Oreo's crater after sunrise at Mount Lady Nikita? So looking at the graph, what's happening is, now remind yourself that it's the red one here, that's Oreo's crater. So Noya's here, and he needs to wait until gets a temperature of 0 before the ice starts to melt. So what we're trying to find is from the beginning up until this point, how long is that? So how long is he waiting for that ice to melt? So find that intersection point, or actually it's 0 because it's an x-intercept for this graph. So it's asking you which graph, graph 2 or graph 1. So we want graph 2, and the x-intercept or the 0 point is about there. So reading that is 2.1 days after sunrise. So that's your answer here, 2.1 days. Noya will have to wait before the ice actually melts. It's a long wait, Noya. Then lastly we've got Lucas, our executive, our NASA executive, who is claiming that there's an amazing view from the top of Mount Lady Nikita that is visible provided the temperature is 80 degrees or more. He then goes on to claim that it lasts for more than a week, and we need to tell whether he's telling the truth or whether he's lying to us. So Mount Lady Nikita is our blue graph, and we get the beautiful view as long as it's over 80 degrees. So the first thing I need to do is actually draw the line at 80. So you can see there it crosses the blue graph at this section here. So when does it first reach 80 degrees? So we're going to find that first intersection point. And it's graph 1 and graph 3, and the intersection points around there, so just grab that over there. So it's 11.5. Find the other intersection point between graph 1 and graph 3, and it's, just bring it over here so I can read it, 15.75. So we will need to find the difference between the 15.75 and the 11.56. So 15.75 and 11.06, I think I said. So that's 4.69 days. So, oops, So it's 4.69 days between here and here. So Lucas is only going to see that beautiful view from Mount Lady Nikita for 4.67 days. So when we're asked, is he telling the truth, he's claiming that it lasts more than a week. Well, it only lasts 4.67 days. So therefore our young Lucas is telling a little bit of a lie and not telling the truth. And that's it for example 3. So again, hopefully that makes sense, and any questions, just be sure to let me know. Cheers.